right, so now we're talking about arithmetic sums, which is a series. So we're going to just really focus in here on arithmetic series. If you remember, a sequence is when you have a set of numbers, a bunch of terms, and they're all changing by a different thing, something that you add. Now we're going to talk about an arithmetic series, which is the sum of a sequence. So here we have a nice problem. Your grandma tells you she's going to give you a penny today, 2 pennies tomorrow, 3 pennies the next day, and so on for 100 days. How much money will you have after 100 days? And my challenge would be, how fast can you solve this? I want it fast, 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 fast. And I want you to do it another way other than going 1 plus 2 plus 3 plus 4 plus 5 all the way to 100. So let's talk about this. The one way that we had and what came up in class is that, kind of let's get a visual. We're adding, and we usually use these dot, dot, dots to show that we're adding a set. 1, 2, 3, 4, all the way up to 97, 98, 99, and 100. So the way that I thought about this is I thought, well, you can kind of do this quickly if you group values together. So if I grouped the 1 and 100 together, I get 101. If I grouped the 99 and the 2 together, I get 101. If I group the 98 and the 3 together, I get 101. If I group the 96 and the 4 together, I get 101. In fact, I kind of surmised that I'm going to get a whole bunch of 101s. And exactly how many? Actually, I'm going to come up with pairs, and there's going to be 50 101s, which would be 5,050 pennies, which translates into $50.50. So we would get $50.50. By taking the first and the last and then kind of adding them all together, I found a pattern, and I found that I can find quickly my answer. All right, so I knew that I'm going to have a whole bunch of groups of 101. Well, it turns out that that's kind of how we look at our formula here. That the sum, and this is our sum, of any series is the number of items, in our case it was 100, but in a number of items, whatever it is, times the first term plus the last term. Okay? So where n is the number of terms, a sub 1 is your first term, and the next one is a sub m is your last term, and then we can always find it out. Now, there are lots of times where you're not given the last term. They might give you a problem, and they might say something to the effect of, okay, I know we have 3, 6, 9, etc., 12, 15. What if you add up all of those, and we added up the first 40 terms? Well, you can say, well, I know the rule is your first term plus your last term, and then you take your number of terms divided by 2. That's what you multiply by. We don't know the last term. So what you would have to do in this case is you'd have to figure out the last term by using our formula. Excuse me, D minus 1. All right. Well, we could plug this in for our a sub n, and that's what I'm going to do here with this formula. It's okay. I actually don't like using it. I actually like using calculating. You'll see me in another example. I'm going to calculate the a sub n off to the side and then plug it back in. But if you want it all in one formula, here it is, all in one formula. So let's look at some examples here. Now it tells us here my first term and my last term. And then we want to know what is the sum of my first 60 terms. Well, I know that my sum formula is I take the number of terms divided by 2, I take my first term and my last term, and I add them together, and that's what I multiply by, those number of sums divided by 2. So here it's going to be 60 divided by 2 times 9 plus 304. Okay, 60 divided by 2 is 30, and we have 313. 30 times 313, I have a 0 here, 939. There we go, 9,390, and that's my answer there. That is my S sub 60. All right, so the 60th term, if I added all those values together. Now we talked about what if I don't know that last term, 1, 4, 7. Well, the first thing I need to figure out is, hey, D is 3, and I can do that just kind of logically. I could take the second term minus the first term. So then what I would need to do is I'd first need to figure out what is my 12th term. What is that A sub 12? So I'm going to use my formula, say the first term plus the difference times the number of terms minus 1. So I'm going to say 1 here times 3 times 11, or 1 plus 33, and my answer here is 34. Now I can take that information and say, well, then the sum is going to be the number of terms divided by 2, and it's the first term plus my last term. Well, I happen to know that my last term is 34 because I just calculated it here. My A sub n is 34. So now it's really what is 6 times 35. 6 times the 5 is 30. 18, 210 is my answer there. So now, really that's the end of this. I kind of wanted to go quickly. This is for people who missed going through in class some of the things when we had we talked about what is the sum. So let's use it here. Okay. So all right, so let's look at our worksheet. This is the 12.1 worksheet that I handed out. Let's look at the first problem. In each hour, the grandfather clock chimes a certain number of hours, and that corresponds to the time of day. At 3 o'clock, it chimes 3 times. How many times does a clock chime in one day? So we want to know the sum of the 12 times. We're going to start with 12, and I'll talk to you here about what that means. Let's just think about what does it do in a half a day. How many times does it chime in 12 chimes? When it starts at 1 chime, and I got to move this over. It starts at 1 chime, and it goes to 12 chimes at midnight, and so we have 12 values here. Okay, so we would be looking here at 6 times 13. So 6 times 13 is 78, but that's in half a day. We would have to double that because it happens twice in a 24-hour period, because it says in a day is 24 hours. And so we would have to make that 16, 14, 15, 156 times. So we have 156 chimes in a 24-hour period. In 2, logs are stacked up in a pile. There's 24 logs in the bottom row, 15 on the top, and there's 10 rows in all. So we have 10 rows in all. We want to know the sum of all these log of all 10 rows. On the first one, there's 24, and on the top one, there is 15. Okay? So really our problem becomes 5 times 39. 5 times the 9 is 40, 190 logs is what we're talking about there. Let's pick and choose a few more here. I think the first couple you should be able to just kind of figure out. We're trying to say, okay, what's our D? What is it working with? Now, one suggestion I have for 4 is to look at it without the ends in it and say, okay, what's changing? So if I did it without the ends, you might say from here to here that changed by 6. I subtracted 6, added a negative 6. So there's negative here. From here to here, there's another negative 6. And so each time I should just be going negative 6. Well, the fact that we really actually technically have this n here too means that we're just taking and we're subtracting 6n each time. So my next one here would be 13n, and then negative 19n, and then negative 19, negative 20, what do I have, 6, 25n. Okay? I think I showed you already how to do 5 and 6. Let's look at a little bit more difficult one. We know how to do 7 and 8. We did a bunch of these. Let's talk about a summation problem. I do want to mention that some of them might be a little different than what you see on your paper. I think I did have to fix 11. Here, in number 11, I do have a typographical error. Instead of the 6th one and then a 6, this should be 26 here, guys. So sorry about that. Please change your paper to reflect that it should be a 26 there. I'm trying to see if I have any others that I really want to look through. I want to look through a series or where we have a sum. Like, let's look at 15. Find the sum of the first 100 terms of this. Well, what I'm going to have to do first with 15 is I have to go and I have to find the 100th term, that last term. So I have to take the first term, and then I have to have my d, and then I have to go 100 minus 1. So I have to figure out my d. To figure out my d, I take the second term minus the first term. And so really what I get here is it comes out with 0.2. So here I really have my 0.2 in here. So I have to do some calculation there. It is really 99 times 0.2 minus 5. Let me do that on my calculator here. I had 99 times 0.2, and then I subtracted 5 from that. So I got 14.8 for my value there. So this was here is at 14.8. That's what my last term was. So then what that means is when I'm looking at my sum, we're talking 100 terms. My first one is -5. My last one is 14.8. And I can work it out from there. So really I need to go 9.8 times 50. Okay? So let's do that here. 9.8 times 50. I got for an answer of 49. So my answer here was 49. Good luck, and I hope for you to get this worksheet done.